everyone. So let's discuss this vector question. The diagram shows a square, A, B, C, D. Now, when you see the keyword, the shape, yeah, the square that shows that all sides are equal in length and the opposite pair will also parallel. Okay, and P is the point on side AB and the Q is on the diagonal BD. It's here. And now let's fill in the important information. So we have AP equals to X. That means, let's put it here. A to P is X. Okay, and A to D is Y. And AP, now this is very important. If AP, we write in fraction form with PB, okay, because the fraction form shows the another way we write the ratio that shows that if the length AP to PB is 1 to 2, or we can put vector AP. So vector AP is one part. So where's AP? AP is at the X here. So let's just put 1 with the circle to indicate that this is the ratio. And P to B is 2 parts. So if X is one part, therefore from here we will have PB, which is equivalent to 2X. All right, so we have PB, the vector PB is found, which is 2X. And then what else? It say BQ is, so BQ over QD, right in fraction form, so that we can compare. BQ is 2 parts, so it's BQ. Okay, it's on the diagonal. This is 2 parts. And then from Q to D is 3 parts. Okay, let's just put like this. So 2 parts and 3 parts. Okay, so once we have done this, then we can find the vector PC and vector PQ. All right, so let's find A, PC. Okay, we have to look at the diagram. Use the diagram to help us. Now, the one that we have, the a vector, let's highlight it so that we know that these are the existing path that we have. And because this is a square, so basically all sides we have. Okay, all this path we have. The one that is the opposite pair will always be parallel. That means BC is also Y and DC is altogether 3X. Yeah. Now we want PC. So where is P? P is here. So P to move to C, we can just easily choose P to B plus B to C. Yeah, always break it into 2 paths and whereby you have a common point. Yeah, the bridge to connect these 2 points. So PB is 2X and BC basically is the same as AD, that is Y. So let's just put the Y there and we found the answer. Okay, and then part 2, we want to find BQ. Okay, where is BQ? Okay, BQ is here, from here to here. Now, do you see that the BQ, we have the ratio marking here? That means we can write the BQ in terms of BD. Always connect from the blue point, the point on the blue path to another point on the blue path, because the blue path is the path that we have. Okay, so in this case, B to Q is actually 2 parts out of the total. You see, got 2 plus the 3 parts, so 5 parts. Yeah, that means from B to D we have 5 parts because 2 plus 3. Therefore, BQ is 2 out of 5 of BD. Must be in the same direction. And 2 out of 5 of BD. BD is B. We can use BC plus CD. Okay, if you can see the vector right away, just put in. We know that B to C is Y. You can straight away put a Y in without writing this, but I have the habit to write, to break down any vector into two paths, so we will not miss out anything. So BC is Y, and C to D. Now D to C, you see the arrow here? So now we are going against the arrow, so must remember to plus a negative, which is give us negative, negative 3x. That shows the direction. So you can just leave this as your answer, or you can just multiply the 2 over 5 in. So we will have 2 over 5y minus 6 over 5x. Okay, both are acceptable. Now, next, part B. When you see, we need to show the point B, Q, C are collinear. Whenever you see collinear, the keyword is the same concept as parallel, yeah? Because collinear, they're on the same line, therefore, you know, the line must be parallel. This line segment must be parallel to the other line segment, parallel to the whole line segment. Okay, so use the concept of parallel. So PQC. So let's write the hypothesis. Yeah, if P, Q, and C are collinear, then now we have PC and BQ. Okay, so we can just put PC can be written in lambda. Maybe we put PC, we put lambda PQ. Doesn't matter how you join. You join P to Q or P to C or Q to C, up to you, yeah? So I choose PC because I have PC on my A part 1, and then the rest, I just choose any lah, PQ or QC. Should be fine. All right, remember, this is the hypothesis that we should always start with when you see the collinear question or shows that two vectors are parallel. Okay, if PQ and C are collinear, then PC equivalent to lambda PQ. Now, PC, we have the vector, which is 2x plus y. Lambda, just leave it. What is lambda? Lambda is the thing that we put, which we need to find it later. And PQ, how do we get P to Q? We can get P to B plus B to Q. Yeah, BQ is already found in part 2, A part 2. So B, okay, so just put in lambda. P to B is 2x. BQ is 2 over 5y minus 6 over 5x. Okay, let's group the x together. We have 2 minus 6 over 5. So we will have 4 over 5 x. Don't forget to multiply the lambda in here. So it will be 4 over 5 lambda. Let's see. Yeah, and then plus 2 over 5 lambda y. Okay, so now we have both sides contain vector x and vector y. So the next step is always compare coefficient, always. Okay, let's just focus to this. The next part will be compare coefficient. Coefficient will be the number that attached to the vector or to the variable that we want. So for vector x, on the left-hand side, the coefficient is 2, and on the right-hand side, the coefficient is 4 over 5 lambda. And for vector y, on the left-hand side, the coefficient is 1, and on the right-hand side is 2 over 5 lambda. So over here, we can find the value of lambda. So it will be 2 times 5 over 4. Rearrange the equation. So you will get the lambda to be 5 over 2. And happen to be on for the coefficient of y, your lambda will be 1 times 5 over 2 as well. Therefore, lambda equals to 5 over 2. See, both side, you get the same value of lambda. That means lambda exists. That means we can write, since PC can be written in 5 over 2 PQ, okay, therefore, as long as we prove that vector PC is able to be written in another vector, therefore, we already proven that it is collinear. Now, let's check with PC and with PQ. Yeah? PC is here. This is PC. PC is the one that is bigger. PQ is the one that is shorter. So our lambda makes sense. Yeah? Our lambda makes sense. Okay, since PC can be written in the lambda PQ, whereby the lambda exists, therefore we have just proven P, Q, and C are collinear. That's it. So to prove collinear or to prove parallel, the SOP will be always write your hypothesis first. Your hypothesis will be if, this one, if whatever point are collinear. This is my hypothesis, okay? And then our objective is to prove that the lambda exists. So we just put in the vector PC and vector PQ, calculate, compare coefficient is one of the important steps. And then finally, we prove that lambda, the same value of lambda exists. If you got lambda 5 over 2 for x, but lambda equals to 3 for y, that means the lambda contradict each other. Lambda does not exist. Therefore, the proving step is failed. Okay, so to prove that they are collinear, lambda must exist. That means lambda, the value for lambda must be able to obtain from the calculation. Okay, so that is how we solve and how we prove the collinear question. I hope it helped you. You may check out my other video on vector, on how to solve the vector questions. Thank you very much.